Okay, here we're going to look at some proofs and some equations using the trig formulae that we've learnt. Okay, the first one is written here. Notice the three lines in the equal sign mean that this is true for any values of a and b, and that's what we're going to try and prove. So we're going to start with the left-hand side, and we've got sin a over sin b plus cos a over cos b. Now, if we look at the left-hand side, we've got two terms, and on the right-hand side, we've only got one. So we're going to combine our two terms on the left-hand side. When we add fractions, we have a common denominator. So we're going to start off with a common denominator of sin b cos b. Okay, and so the first term we've multiplied by cos b, so the top is going to become sin a multiplied by cos b. And in the second term, we had cos b on the bottom. We've now got sin b cos b, so we need to multiply the top by sin b. So we've got sin b cos a. Okay, let's just make that a little bit longer. Okay, so now what we're going to look at is see if we recognise any of this from our identities. So we have sin a cos b plus sin b cos a. Hopefully we recognise that as sin of a plus b. If we look at what we're aiming for here, that's close to what we want. We've got this 2 that we haven't used yet. Okay, but if we look at the bottom, we're looking for sin of 2b. We've got sin b cos b. Well, that's actually a half of 2 lots of sin b cos b. Okay, and so we're going to write that like that for the moment. So on the top, we've got sin of a plus b. On the bottom we've got a half of sin b cos b. So we can write that as sin of a plus b over a half of, hopefully we recognise this one, of sin of 2b. Then if we multiply top and bottom by 2, we end up with 2 sin a plus b over sin of 2b, which was what we wanted. So that's equal to the right-hand side, and our proof is completed. Okay, now this one, we've got tan of 3a. We don't have an identity for tan of 3a, but in fact we do, because this is it. And how we're going to prove that one is to rewrite it as tan of, instead of 3a, a plus 2a. Obviously a plus 2a is equal to 3a. And then we're going to use our identity for tan of a plus b, where a is a, and our b we're going to replace by 2a. So we're going to have tan a plus tan of 2a all over 1 minus tan a tan 2a. Okay, that's just using our tan of a plus b identity. Then we're going to have to use our tan of 2a identity in 2 places, top and bottom. So we're going to have tan of a plus, now tan of 2a is 2 tan a over 1 minus tan squared of a. So we've replaced that tan 2a on the top. And similarly on the bottom we've got 1 minus tan a multiplied by tan of 2a. So we've got tan of 2a over 1 minus tan squared a. Okay, now it's quite big. I'm just going to try and make that a bit smaller. Move it up a little bit. Okay. So now what we notice again is that we've got 2 terms that we want to combine. So we're going to put a common denominator on the top and bottom of the fraction. So each time it's actually going to be the same. It's going to be 1 minus tan squared a. So that I'm just working on the top of the fraction at the moment. This term was already over that denominator, so we'll just put that as 2 tan a over 1 minus tan squared a. But the tan a wasn't over that denominator, so we need to multiply it by the denominator of 1 minus tan squared a. Just about room for a plus in there. Okay, so that's the top of the fraction. Bottom of the fraction, again we're going to have 1 minus tan squared a as our common denominator. This term is already over 1 minus tan squared a, and we've got tan a multiplied by 2 tan a, so we can write that as 2 tan squared a. And the 1 wasn't over that denominator, so we're going to multiply the 1 by the denominator. Okay, and then we've got minus our sign there. Okay, so now Again, I'll just make that a bit smaller, move it over here, so I can continue on. Okay, so now the top of this fraction, we've got tan A minus tan A times tan squared A, which will give us tan cubed A, plus 2 tan A, all over the denominator of 1 minus tan squared A. And on the bottom of the fraction, we've got 1 minus tan squared A minus another 2 tan squared A, so minus 3 tan squared A, all over 1 minus tan squared A. Okay, nearly there. Okay, now because we've got the denominators the same, we can actually cancel those out. You can think of that, if you like, as turning the fraction upside down and then multiplying, and equally they will cancel out like that. Okay, so we've now got left on the top tan A plus 2 tan A will give us 3 tan A minus tan cubed A. And on the bottom, 1 minus 3 tan squared A, which is what we wanted on the right-hand side. Okay, I've just remembered I forgot to put at the beginning here, left-hand side equals, always good to start a proof like that. Okay, so that's that one completed. We're now going to look at a couple of equations. The first equation is to solve sine of 2 theta equals cosine of theta in the range 0 to 2 pi. So we're going to just write the equation out to start with. Okay, so sine of 2 theta we know is 2 sine theta cos theta, and that's equal to cosine of theta. Now, it's tempting but wrong to cancel out the cosine theta at this stage. If you do that, you will lose some of your solutions. A better way around it is to take the cosine of theta to the left-hand side as well. So we'll have 2 sine theta cosine theta minus cos theta equals 0. We can then factorise, so we take out cos theta, 2 sine theta minus 1 equals 0. So we've either got cos theta is equal to 0, or 2 sine theta minus 1 is equal to 0. So if cosine of theta is equal to 0, then we know from our cosine graph, which I'll quickly draw here, that we've either got theta is pi over 2 or 3 pi over 2. So we've got these two solutions here and here. Okay, if sine theta minus 1 is equal to 0, then sine theta is equal to a half. And one of those solutions is pi over 6, and the other one, that's pi over 6, that'll be pi minus pi over 6, there'll be 5 pi over 6. Okay, let's look at this equation now. Okay, so we've got 4 tan theta. I'm going to go straight in and expand my tan of 2 theta. So that's going to be 2 tan theta over 1 minus tan squared theta. And that's all equal to 1. Okay, so if I multiply these two terms together, on the top I'm going to have 8 tan squared theta. And on the bottom I'm going to have 1 minus tan squared theta. That's equal to 1. So multiplying both sides by the denominator, I'll have 8 tan squared theta equals 1 minus tan squared theta. Okay, so I'm going to take that tan squared theta across. So I've got 9 tan squared theta equals 1. Tan squared theta equals a 9th. So tan theta is plus or minus a third. Okay, so if we have tan theta is a third, plus a third, then from the calculator, one of the solutions is theta is 0.32. Okay, quick sketch of tan in this range. Okay, so if I've got tan theta is 0.32 here, then the other positive solution to tan theta is positive a third is here, and that's going to be 0.32 minus pi, which comes to minus 2.81. Okay, if I look at tan theta is minus a third, then I'm going to have theta is minus 0.32, or the other solution over here is going to be 2.81. Okay, done. Those are the solutions, 1, 2, 3, 4 of them.